Okay, so we're gonna take a look at division of polynomials in this video. Division of polynomials. Okay, now let's take a look at just kind of division in general, let's say integers, right? So here we sometimes write as this, and then we do 3 times 12, excuse me, 3 times 4, which is 12, and we get 0, right? And that would be, we have a remainder of 0, right? And we can say that 4 is a factor of 12, right? Now, for something like, let's say this, right, if we do 4, 13 now, still 3, right? It doesn't go any further than 3. So 4 times 3, 12, subtract, we get 1, so we have a remainder of 1 in this case. All right, so we're going to introduce something here called the division algorithm, right, which is follows for integers and will also follow for our polynomials. All right, so that kind of ties this idea of division uh, into our operations of multiplication. So the division algorithm means that this is true because this is true, right? 12 is equal to 4 times 3. Now, when there's a remainder, excuse me, let me try that again. 13 equal to 4 times 3 plus 1. Okay, so we can write it like this. Right now, this here, so this is called the dividend. This one here is called our divisor, what we're dividing by. This one is our quotient, how many times it goes into our dividend. And then lastly, our remainder. Right? In the case of 12 is equal to 4 times 3, if the remainder is 0, then the divisor, then we can say the divisor is a factor of the dividend. Okay. All right, now how does this relate to our polynomials, right? So we're going to do this. This is long division, this idea of long division using our polynomials. All right, so let's see. So now we'll do long division of polynomials. Okay, so the idea here is to be able to do a problem like this, right? Divide 2x cubed plus 3x squared minus 4x plus 15. Divide this polynomial by x plus 3. All right, and we're going to be using long division. Okay. All right, so here we'll set up here. This is going to be my divisor, x plus 3. And then here our dividend goes in here. Okay, now the idea here is when we approach a problem like this, right, I want to focus on only the first term here, right, the x and the 2x cubed. Okay, so the plus 3 will play itself out, but really what I'm interested in, similar to what I did with our division here, is to either get it to 0 or at least get this to be some remainder left, right? Now, in terms of our x values, here I have an x cubed, and this is x to the first power. So what I want to do is I want to match up our first term in our divisor with our first term in our dividend. Right, so there's no coefficient of 2, so I'm going to multiply by 2. Now there's an x to the first power here, but I need an x cubed. So I'm going to multiply in 2 more factors of x. Okay, so that's going to be 2x squared. All right, and then the idea here now is, if I do the work here on the side here, is 2x squared times x plus 3. All right, you distribute that out, we get 2x cubed plus 6x squared. All right, and then here, I'll write that in here, 2x cubed plus 6x squared. All right, and then from there, we subtract, right? Similar to our division, long division of integers there. So notice here that that goes to 0, and then we get minus 6x squared, so we get minus 3x squared. And here I'm going to bring down the negative 4x. You can leave it up there if you like. And in fact, let me just work this way like this, minus 3x squared. Okay, and again, the next step is make sure to, I want to try to eliminate, like I did a 0 here now for the x squared. And I can still do that, right? This is a factor of x squared, so, and then a minus 3, right? So I want to match that up here. Okay, so doing the same thing that we did here, minus 3x times x, minus 3x squared, and then minus 6x. And we subtract, so that goes to 0, we get plus 6x minus 4x, we get 2x. All right. Okay, and then we can do this one more time, right? This has an x and an x there, so no more factors of x that are needed. All right. So only thing needed here is that coefficient of 2. So, right, so when I multiply that, we get 2x plus 6. Subtract, that goes to 0. 15 minus 6 is 9. And now I know that I have to stop right here. Okay, now how do I know that? All right, well, here there's no more factors of x, so whatever I multiply into here, I'm going to get some kind of factor of x, which I no longer have any use for. So at this point, I can stop. All right, so at this point, what we have here is we have our dividend. I have that equal, excuse me. Let's try that again. Our dividend, 2x cubed plus 3x squared plus 15 equals to our divisor, which in this case is x plus 3, and our quotient, and then our remainder, plus 9. Okay, so again here, now we have similar parts here, where this is our dividend. We'll call it f of x. Right, this is our divisor. Which we'll call d of x, our quotient, q of x, and our remainder, we have r of x. Sometimes it may contain an x, just really depending on the degrees of our polynomials. One thing to notice here is that once we perform this division, since this is a power of 1, and we are dividing a polynomial of degree 3, notice that the quotient is 1 degree less. All right, and that is the kind of pattern that we'll see, right? If we have degree 5 and we divide by a linear term, something of degree 1, then the the quotient would be of degree 4. Okay, so just keep that in mind, right? And the same thing here, if there was 0 remainder, then we would say that x plus 3 is a factor of our quotient, right? But in this case, we do have a remainder, so it is not a factor. All right, let's take a look at one more example here. Okay, so here we want to divide 4x plus 5 into 16x cubed minus 12x squared plus 20x minus 3. All right. And again, the same approach here, right? I'm going to look at eliminating the 16x squared. So we have an x cubed. This is x to the first power. So I know I'm going to have to multiply in 2 factors of x. And then I'll match up the coefficient. So this is 16, this is 4. So we'll multiply by 4. All right. Okay. And again, don't worry about the rest. We'll do these one step at a time. We always focused on that leading term. So multiplying here, we get 16x cubed plus 20x squared. All right, we subtract, and that becomes 0, and this becomes negative 32x squared. Okay. All right, and again here, just focus on this leading term here. So coefficient of negative 32, so I'm going to multiply by negative 8. I need an x squared. We have 1 factor of x, so we only need 1 more factor there. So we get negative 32x squared, and then here we get negative 40x. And then we subtract. So that becomes 0, and then here plus 40, we get 60x. All right. Okay, and then lastly, matching up here, we can do this one more time, right? We have factor of x here, just match up the coefficient. Positive 15, we get 60x plus 75. We subtract, goes to 0, negative 78. All right, and now we can stop here, right? X, there's no more factors of x, so we are done here. All right. So now we can write our dividend. To be our divisor times the quotient plus the remainder, in this case minus 78. All right, and in general, our division algorithm for polynomials looks something like this. All right. Okay, so f of x dx times qx, right? Divisor, quotient, the remainder. And then really also we can think of polynomials in the numerator here written where f of x divided by d of x, right? That's exactly what the long division is that we're doing, that we're representing in our long division there. Okay? All right. In our next video, we'll take a look at a synthetic division, maybe a more straightforward approach, a faster approach to this technique here.